Now we're going to take a look at a term called outwash. And so, as the name implies here of wash, this is going to be related to a lot of water. So, what happens when a glacier melts is obviously we have a huge chunk of ice suddenly melting. So, that melting water has to go somewhere. And of course, it goes down slope. So, one of the things we see as far as outwash, it starts to essentially deposit sediment via moving water, via the meltwaters of a continental glacier. So typically we find the deposition that's going to flow beyond the end moraine. So the end moraine, essentially the extent of the glacier, essentially melts in spot and melts in its place, and then that water then of course is going to flow down slope beyond the end moraine. One of the things is you're going to see here in the case of outwash, which is different than what we saw in the till plain, is here we're going to see sorting. And so that outwash, particularly sand, silts, and clays. And so the outwash, essentially the water is taking the sediment and moving it away from the end moraine. And it can only carry, water can only carry so much. It goes back to previous things we talked about regarding fluvial processes. And so what happens is it then sorts out the sands, silts, and clays based on gradient. So it's initially the sand is kind of deposited and left behind, and the silts and clays are carried on. And then as that river slowly starts to lessen its gradient, the silts and clays are laid down and so forth. And so you start to getting these layerings, these sorting that happens related to fluvial processes in the case of outwash. Meanwhile, at the end moraine, the bigger stuff, the boulders, the unsorted gravel is essentially left behind because water can only carry so much. Glaciers can carry anything. Where water, it's a little bit more selective. It can only carry our finer grain or smaller grain sediments. Further, one of the things you'll note with outwash, especially beyond an end moraine, is a lot of carving out of the meltwaters, carving out river valleys. And once again, these V-shaped valleys. So you're going to see river valleys all throughout areas where glaciation happened. And essentially that water, it melts, and we're talking a lot of water. And as it melts, it's of course going to flow down slope. And as it flows, it carves out these river valleys that we're going to see all throughout the state, but especially in southern Indiana, very clearly seen on our topographic map. So here we have the extent of the end moraine. So we have our glaciers. Down here is Evansville and the lowest point in Indiana. So everything's going to flow. If you think about water, the meltwaters, everything's going to flow in this general direction from the northeast to the southwest. Important to keep in mind. So once again, these huge blocks of ice, they melt. All that water has to go somewhere. And then, thus, we superimpose our rivers are good as far as transporting that melt water. And so over time, these river valleys are essentially carved from the meltwaters of this particular a continental glacier. So all this area here then is comprised of what we would call outwash, that sorted sediment of sand, silts, and clays. And once again, the glacier, the end moraine is where the big stuff, the boulders, the gravel, the bigger sediments are left behind. So all this area here represents areas of outwash. So how do we relate this to outwash? Once again, the general profile of a river system. We start to have these layering. We start to see this situation where the boulders are left behind. So we think about an end moraine. The big stuff's left behind, but the outwash continues to carry on the smaller sediments. Then it leaves behind the sands. Then it gets to a less of a gradient, leaves behind the silts and the clays, the smaller sediments, and so forth. And so, once again, rivers and moving water does a good job of layering sediment. Glaciers, when we think about them, they don't. They just essentially, they're unsorted. They just drop everything in spot. So it's very important to keep in mind. And we can relate this, of course, to the different types of loads. We get the bed loads, the bigger stuff that stays behind, stays at the bottom, whereas the lighter stuff stays at the top and can be carried farther distances. So with all this in mind, which one of these pictures is glacial till and which one of these is outwash? And the answer is this over here is glacial till. This over here is outwash. You can see the layering. See the layering here. It's sorting things. That's what I mean by sorting. Different discriminates. Heavier stuff at the bottom, lighter stuff at the top. In the case here, glacial till, it just essentially drops everything in its spot. It just dumps it. And so you're going to have big boulders mixed in with smaller sediments, little chunks of gravel, and so forth. So here on the left, glacial till. Here on the right, outwash.